is we're going to have a dot, a thing, pop into our world every so often. And so the world, right now, our world does not have an act method. I hope it doesn't. Yep, it kind of does. Um, no, it doesn't. So we're going to be adding one to this world. So it currently does not, but we will be giving that. And then so the world is the one that is in control of adding these objects. So um, similar to what we did with the box guy, he had a step counter, and when that step counter got to a particular point, he was going to turn. The step counters are used a lot in different games. We're going to create a step counter for the world as well. And the world is going to look every so often, every 100 steps, every however many times we want, depending on the rate of that we want this to get added. We're going to add another object to our world. And the first one that we're going to add is we're going to create a dot. All right. So I'm going to get a new subclass, and I'm just going to call this dot which object you want. So the thing is just going to sit there. So a rock would be a good choice. I'm going to have a ball just show up. Um, and the problem is that this dot is kind of large. So if I make a new dot, that, well, maybe for now we'll keep that in. We'll worry about changing its appearance later. So the dots are going to be a little larger than what I was thinking. So there's a dot. The dot is not going to move. It's not going to go in a box or a triangle or anything like that. It's simply going to sit there, but we want it to disappear after a certain number of steps. So what's the algorithm for that? A certain number of steps, a certain number of times that it's acted. That means that we're going to need a step counter similar to our box critter, right? So we'll create a private variable. We'll initialize that to 0. We'll increment that by 1 every time that the act method is called. And then when it reaches its lifespan, whatever we want to say for that, 150, 200 steps, something like that, then we want it to disappear from the world. All right. So its act method won't be very complicated, but we will need to initialize that private variable, similar to what we did in box critter. And then we need to get it to disappear. How do we do that? Well, let's take a look for a moment at the documentation for an actor. And if I look through the whole list, there's act and added to world, get different things. None of that looks right. Getting X. There's some stuff. There is a remove touching. That's helpful if I have two objects that collide and I want the other guy to go away. That's good. But I want this guy to go away. He's not touching anything. It's so if you have a guy that's eating things or bullets or laser beams that are coming through and you want uh, that laser beam to disappear or the other guy to disappear, you can do that. And then we're done. There's nothing to remove an actor from the world in actor. However, there is such a thing in the world class. So if I scroll down here, there is a remove object. I can remove all objects. So I might have I don't know, things going crazy and I want all the evil guys to go away. And just so anything that is an evil critter will then get wiped out. This guy, this remove object, that's how to remove a single object from a world. Oh, okay, that looks promising. But the issue is this is in the world class, and I'm a critter, I'm an actor. So how can I do that? If I go back to, so that there is a method that is going to do what we wanted to do. We just have to figure out how do we get that. In one of the getters is I can get the world. That returns the world that I'm in. Once I have the world I'm in, then the world can call the remove actor. So there's a couple of dominoes that need to fall before we can get this guy to disappear. You might think about writing to Michael Cohen and saying, you know what, the actor should really make himself. But the reason for it is that the world is in control of all the actors, and so that's why the actor is doing that. I can't add myself. I can't add another uh, object in actor. I've got the world's got to be able to do that. So that's the reason that Michael Cohen did it that particular way. So I'm going to leave you to figure out how to do. So we need a step counter. Take a look at your box critter class. Um, and you want a private variable. You need to create a constructor similar to what we did for box critter. There's no return type on a constructor. It's going to be public dot in my case, or whatever you call it, your object, spelled and capitalized correctly. And then the first thing that needs to happen inside our act method is that step counter needs to go up. So I'm going to do that myself. You do it on your own, and I'll start this shortly. All right. So here is, so I have that going. I'm in my dot class. And so here is the act method for the dot. The dot isn't going to do a whole heck of a lot, but its step counter is going to go up. So if you watch the modulus thing, you know that is a way of incrementing a variable by 1. So it's going to go up by 1. Every time it acts, I want step counter to go up by 1. Now I want this thing I want it to disappear. So keep going up, keep going up, keep going up. I don't know. How does 300 steps sound? So some value. So if this dot step counter is greater than, so is it equal to, or do I want greater than? The only issue with doing a equals then is that if I decided I want the step counter to go up by 2 or some other value, it might jump over that double equal sign. So this is a way of preventing a problem down the road. All right. So if I knew that this is just for Clifford, it's just we're going to be moving on from this, doesn't really matter, that's not going to, then doing a double equals, the only is he's at that variable is only going to go up by 1. It eventually will equal that value. Then you can do certainly a double equal sign is fine. You're going to see this a fair amount. This is kind of a protection. All right, so I want this guy to go away when that step counter is greater than 300. So it's going to get all the way there. And if I want step counter to increase by 5, or I wanted to increase by 10, or some other multiple, then this is going to prevent, if it were equal to, it might jump over it, and it would still be there well past that 300 limit that I want. All right. So that's a way of that. This is my test. And now I want this thing to disappear. All right. So it would be great if I could remove itself. So this dot remove. This is not going to work. This. All right. So the keyword this, I've thrown that around a little bit, and I think you've just kind of gone with it. Good thing. The keyword this refers to the current object. This is a way of referring to the instance variable that I created. So I want this guy's step counter. Would it work if I didn't have that identifier? It would absolutely work. So that is a legal thing to do. And back in the day, Java, that's what you did. The current standard of writing code, however, says that data that is methods of a class and instance data that is specific to this given object, need to have an identifier. So it will work. It will kind of grandfather you in. But the key, this refers to the instance variable step counter that is private to this given object. So anytime you see the word this, it is referring to this object's instance data or this object's method that we've defined. there is no remove. So what's barking here is it cannot, there is no remove myself from this thing. And it's noticing, oh, you've got move. Maybe that's what you meant. So that's a nice thing that's going on. So that's not going to work. What I want instead is I need to get the world. And so that's where we were looking at this guy. There's a get world. And what does that return? Oh, it returns a world. So I'm going to do that. I'm going to create a variable that is type world, right? A little esoteric perhaps. And I'm not going to need it very long. World W isn't the world's greatest name, but it's going to work for this purpose. So I'm going to store the current world in a temp variable W, and it's going to be this dot get world. Now that I've got the world linked to this variable, now W can remove object. But let me go back and make sure that's correct. If I go to the world class, here's the world class, and down under R, there's remove objects plural. That takes a list. This is remove object singular. That takes an actor. So that is the one that I want to use. So it's going to be remove object singular. And I can't do that. Hopefully this will make some sense. Remove object, no parameter, nothing in between the open and the closed parentheses would be, it doesn't know which object do you want me to remove. You want me to remove the critter, the box critter, the dot, which dot? So that keyword that I was just talking about, this is how that's going to be done. This is the object. I want you to remove me, remove myself. So keep adding. You're going to do a test. If the step counter eventually gets to greater than 300, then I'm going to get the world and I'm going to remove the current object from that world. And that compiles. And let's take a look. Here's my dots. The dot, again, a little larger. And it's going to run. That was a little on the fast side, but it did disappear. Hopefully you saw that. New dot, we'll run it. And again, so that's just going up and up and up and up and up and up. And eventually, it disappears, right? If you wanted to test it and just make sure that it was right at that particular spot, you could do a temporary system out of the step counter and watch those numbers go up until it got to 300 and then it would disappear. All right, so that's the dot. And in the next video, we'll talk about how to spawn that from my world.